Randomized block experiments are a method for trying to find out information about a certain subject or situation, as most experiments do. However, this specific method of trying to find information or data does so by organizing the different test subjects being treated for the experimentation into particular groups or blocks, as they are known by here. And they do this before any actual treatments are applied to the subjects. The specific design helps to ensure that all subjects are equally impacted by their treatments in an effective way that allows those carrying out the experiment to know exactly what the impacts of the treatments are to any of the specific subjects. If done correctly, a randomized block experiment ensures that its outcome is very clear and shows exactly the cause and effect relationship between the subject and the treatments without any bias or conflicting data. A key feature of the randomized block experiment is that it helps to reduce any bias in any survey or experiments that you're trying to conduct. And this is the direct result of the randomization portion of the experiment, which randomizes your initial data to make sure that any bias can't be implemented into your final findings. The way to set up your experiment would be to actually divide up the population that you are either surveying or testing, and then breaking up the population into blocks that allow a good representation of the population to be impacted by the treatment or survey that you are using. This is seen here from the example that I have, where you can see that both men and women who are both shoppers and non-shoppers can have their views equally gathered about consumerism without any bias that might come along with it. Here we see a more blown up general view of what the ideas of a randomized block experiment look like, where we have different blocks that combined represent our entire population and individually can tell us what is happening to what objects with what treatments. Different engineers might use this experiment design differently. For example, environmental engineers might use this in the form of experiments to collect data on different treatments that they are testing, while social engineers might be using this design in more survey type scenarios. Here's a basic general view of a slightly more specific scenario where you can see the effects of three different treatments, chemical X, Y, and the lack of chemicals, on two different types of flowers, or the roses and the tulips. Again, it would be important to point out that here the groups of specific flowers that get treated with their own treatments would be randomly grouped to preserve the lack of bias. And ultimately, this experiment would be able to effectively show how each treatment impacts each flower.